Hello and welcome to another Java tutorial, and we are looking at the Java language basics. And so far we've arrived at the end of the looking at the operators. So let's just quickly wrap up the operators by looking at the summary of the operators. And we saw that operators in general, we have a unary type operators and binary type operators. The simplest operator is the assignment operator, and we said that we can overload it in Java with the plugin that Eclipse supports with the static factory method called value of. And the way that assignment operator works is that first the right hand side is evaluated, and the return value of that expression is assigned to the left hand side. And obviously, because Java is statically typed, the types should also either perfectly match, or the type of the right hand side must be in a way that it can be implicitly converted or cast to the left hand side. So it means polymorphism can be used, implicit casting or implicit conversions of the short and byte, for example, to int can be used. Other types of binary operators are arithmetic operators, and we said that plus, minus, multiplication, and division, these you can use these and overload them for your classes with the basically plugin that Eclipse supports. And we said that binary operators can be used, for example, both for the left hand side or the right hand side. What this means, you can overload the plus for your class type by either using the add or add reverse, which means whether your class goes on the left hand side or the right hand side. And we said that Java guarantees that whenever you have a binary operator, the left hand side is evaluated first, and you have to be careful that that might have some side effects on the right hand side. So you have to be careful about the order of execution or evaluation. So we said that the left hand side is evaluated first, and then the right hand side is evaluated, and then the return value of the expressions for the left hand side and the right hand sides are passed to the binary operator, in this case plus or minus, multiplication and division. And we saw that remainder is interesting. We typically, the left hand side, right hand side are integers, and it gives you the remainder. And we said that the most important use case of the remainder operator is for circular buffers, when you have a fixed array size and you fill it up, and then if it fills up, you want to go back and start over from the starting index, then you use the index operator, right? The remainder operator to circulate back. Unary operators, we said that unary operators, the operand is always on the right hand side for the plus, minus. Plus doesn't have really any effect, it's a default, and minus, it negates an expression, and it works on basically mathematical expressions, right? And then we have also logical negation, which means it logically returns the value, flips the value, and it only works on Boolean types. Negate works on, for example, numeric types. Logical operator operates on basically Boolean types. If it's true, it becomes false. If it's false, it becomes true. Plus, minus, minus are important, and they have two types of notations: prefix notation or postfix notation. We had a very in-depth discussion about how this works and what are the pitfalls of using these if we use these in conjunction with each other. For example, if you say y equals plus x plus I don't know, x plus something like that, you should always avoid using compound expressions with these type of increment decrements. Always use them in a one line of code, like just x plus, that's one line of code, or I plus. And we said that in the for loop we typically use for int I equals 0, I less than some upper bound, and I plus or plus I. We said that I plus is less efficient than plus I, because these postfix or prefix unary operators also have return values, which means if you say plus I, it increments the I and then returns the new value, which is the current value of I, right? However, when you say I plus, it has to first store the current value of I in a temporary variable, and then increment the value of I, and then returns the old value, the value in the temporary variable. So it has to do extra work, whereas the plus I doesn't have to use a temporary variable, because it knows that the return value is the new value. For I++, the return value is the old value. That's why it has to do some extra work. And we cannot overload these in Java with the plugin that Eclipse supports. Obviously in C++, any of these operators can be overloaded for your classes. Relational operators, equality, and we said that if we compare reference types, it only compares the addresses. If you want to do a logical comparison, which is tied to the state of an object, then you have to override the basically equals, the equals method from the object class. And whenever we override the equals method, we have to also override the hash code. That's the most important thing, or that's the best practice. Not equal to, and then greater than, or equal, less than or equal. These, we said that in Java, the way these are implemented for your classes are based on implementing the comparable interface, which means you give your class, your user defined class or type, a sort of natural ordering, right? So comparable, it has a method that you have to override, which is the compare to. And we said that interestingly in Java collections, for example, in a set or a tree set or anything that requires uniqueness and order, it always uses the comparable interface instead of trying to, for uniqueness in Java collections, it doesn't use the equals, right? It uses the compare to. And we said that the compare to can return +1, 0, or -1. 0 means they are logically equal. So that compare to interface should be compatible with equals. So you have to be careful about that. Conditional operators, we said that these are logical operators, logical and. The operands are always only booleans, right? Logical and, logical or, and a ternary operator. That's the only operator in Java that accepts 3 operands. And we said that this ternary operator in the bytecode exactly translates into as if you write the if-else statement by yourself. So this is just a shorthand notation. It doesn't have any optimization or anything different. And we said that these logical operators, they do have short-circuiting properties. For the AND, we know that if the left-hand side is false, remember the binary operators, the left-hand side is evaluated first. If the left-hand side is false, then the right-hand side will never be evaluated, and the return value will be just false. For the OR, we said that the left-hand side, if it's true, then the right-hand side will not be evaluated. So this is the short-circuiting property. The comparison operator, we said that instance of is for checking the types at runtime. We want to see if a particular class is or variable or a object reference is of some sort of type, and it also basically complies with the hierarchies of classes, polymorphism, etc. Sometimes this is very important if you want to make sure you're doing the safe typecasting. Bitwise and bit shift operators, we said that unary bitwise complement, and then signed shift left, signed shift right, unsigned shift right. Unsigned right shift, we said that we don't have a unsigned left shift. Bitwise and, bitwise exclusive or, and bitwise inclusive or. And we said that these are very similar in practice with their basically conditional or the logical operators. Note that we don't have a logical XOR for booleans. We don't have that, but you can always implement the XOR in terms of and or. So XOR is not something fundamental. You can always basically implement it. But for the bitwise XOR, we do have a dedicated operator for the bitwise XOR. Alright, this was the summary of the operators, and we can go back and continue with the expressions, statements, and blocks, which is the next important topic in learning Java, right? So what is the expression, what is a statement, and what is a code block? So expression. An expression is a construct made up of variables, operators, and method invocations, which are constructed according to the syntax of the language that evaluates to a single value, and that single value is called the return value of evaluating the expression. Sometimes I say the value of the expression, sometimes I say the return value of the expressions. These all means that you evaluate the expression first, and then figure out what the type of the result is and what is the value of the result is. It's called the return value of the expression evaluation. You have already seen examples of expressions illustrated in the code below. So whenever that you say that int cadence equals 0, this is a expression. and it ends with semicolon, so it's also a statement. So this is one statement that includes one expression. An array at index 0 equals 100. This is one expression and it ends with semicolon, so this is also a statement. So a statement that has one expression. Same with here, this is a statement that has one, actually it has more than one expression, right? So one expression is here inside the argument. So it's a binary operation, which is an expression. The left hand side, right hand side are evaluated, and then the binary is evaluated. And then we have another expression that calls this method. So this is a statement that has, for example, two expressions. Same here, for example, when you say int results equals 1 plus 2, we have two expressions. On the right hand side is one binary expression which evaluates first, and then the entire expression. So this is a statement that has, for example, two expressions. If value 1 equals value 2, we do this. So this is an if statement. We say that if it's a if statement, so the entire thing is one statement. And then it has one expression here for the condition, one expression here for just the string, and then one expression for printing to the console. The data type of the value returned by an expression, which means when you evaluate the expression, the return value is whatever is the result is. Depends on the elements used in the expression. The expression cadence equals 0 returns an int, right? So in the assignment, we said that the right hand side is assigned to the right hand side, and the types should match, right? Returns an int because the assignment operator returns a value of the same type as its left hand operand. In this case, cadence is an int. As you can see from the other expressions, an expression can return other types of values as well, such as boolean or a string. So again, the return or the result of evaluating expression can return any type, anything that eventually the result is. The Java programming language allows you to construct compound expressions from various smaller expressions as long as the data type required by one part of the expression matches the data type of the other. Here is an example of a compound expression. So we have two expressions. This is one statement, two expressions. Each expression is a binary operator, multiplication. And we said that obviously multiplication, when we have two of it, it has the same precedence because it's just comparing with itself. And so that whenever you have operators with the same precedence, the evaluation happens from left to right. So first 1 times 2 is evaluated, the result or the return value is 2, and then 2 is passed to the second binary operator. 2 times 3 becomes 6. In this particular example, the order in which the expression is evaluated is unimportant because the result of multiplication is independent of order. The outcome is always the same no matter in which order you apply the multiplication. However, this is not true of all expressions. For example, the following expression gives different results depending on whether you perform the addition or the division operation first. So we said that if you don't use any pair of parentheses, then the binary operators that have the higher precedence will be evaluated first. In this case, y over 100. And then we have plus, and then it's passed to the next operator, which is plus, and x plus the result of this, right? You can specify exactly how the expression will be evaluated using balanced parentheses. So we said that when we use round brackets or parentheses, it has the highest precedence, and anything inside these will be evaluated first, regardless of the other operators that might be between these the result and other parts of the expression. For example, to make the previous expression unambiguous, you could write the following. So x plus y in parentheses divided by 100. Now we know that the division has higher precedence than plus, right? Addition. However, when we use round brackets around an expression, that gets the highest precedence. So x plus y will be evaluated first, and then the return value or the result will be passed to this binary operator. If you don't explicitly indicate the order for the operations to be performed, the order is determined by the precedence assigned to the operators in use within the expression. Operators that have a higher precedence get evaluated first. For example, the division operator has a higher precedence than does the addition operator. Therefore, the following two statements are equivalent. So either this, you don't use any parentheses, or you use parentheses around the expression that eventually will get evaluated first. Now, my recommendation is that you always use the parentheses or round brackets whenever you're writing this kind of math expressions, because then it makes it much more clear what's going on and which parts are going to be evaluated first. When writing compound expressions, be explicit and indicate with parentheses which operators should be evaluated first. This practice makes code easier to read and maintain. Floating point arithmetic. Floating point arithmetic is a special world in which common operations may behave unexpectedly. Consider the following code. So we have double d1 equals 0.1 plus 0.1 plus 0.1. We are adding up a lot of 0.1s, and then d1 basically 10 of these, and obviously the result should be 1, right? 10 times 0.1 should be 1. However, I said in the previous lectures that never use equality operator for comparing floating points, because floating points have a limited precision. We cannot save them in memory with indefinite precision. Now in this case, the result is a round number like 1, right? So you assume that, okay, if we store it, it's going to be exact precision. But that's not recommended. You better avoid that. You should always compare floating points with some sort of tolerance. Let's say you want to say, okay, I want to, if d1 is close to 1 with a precision of 10 to the negative 5 or 0.00001, then I assume that this floating point number is basically 1, right? So you have to compare floating points always with a tolerance. You would probably expect that it prints true, because if you add up 10.1, you should get 1, right? Due to the way floating point addition is conducted and rounded, it prints false. So the rule of thumb is that never rely on the exact equality operator to compare floating point numbers. Always use some sort of tolerance. Now the double class provides a static utility method compare to, and I believe what it does, it compares the actual bits that those floating point have in the Java heap. So that's one way of comparing. Again, that's not most of the time that's also not what you want. You want to compare floating points with some sort of tolerance, at least as long as you're using floating points to model some sort of physical world, right? Some sort of physical phenomena, because we know that in reality also there is always some tolerance, that quantities have always some tolerance associated with them. Presenting how floating point arithmetic is implemented in Java is beyond the scope of this tutorial. If you need to learn more on this topic, you may watch the following video. And I also recommend you watch this video, Floating Point Arithmetic, what every Java programmer should know. This is a very interesting topic. It's available on Java's official YouTube channel, so definitely check it out. So I'm going to stop here for this lecture. In the next lecture, we're going to continue and finish up this brief discussion on the expressions and statements in Java. I hope you enjoyed this. Please stay tuned, and I'll see you in the next one.